Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss chemical reaction of alcohol, phenols and ethers. Particularly I will focus first with chemical reaction of alcohols. Later on I will discuss chemical properties of phenol and ethers. First I will discuss alcohol. Last class I have discussed preparation of alcohol and phenol. Now I am going to discuss chemical reactions of alcohol. Alcohols are versatile compounds. They react both as nucleophiles and electrophiles. The bond between OH is broken when alcohols react as nucleophiles. First, I will discuss alcohol as nucleophiles. Reaction, I will tell you, very simple reaction. ROH, R is alkyl group, ROH, and you know that O has two lone pair of electron. Then ROH plus electrophile. Suppose carbocation is there. Carbon has positive charge. Then what will be the reaction? I am telling you, alcohol plus carbocation. Then carbocation means here carbon has positive charge. Then oxygen, which has two lone pair of electron, then one lone pair of electron it will give to the carbon because it requires electron. It has positive charge, cation, carbocation. Then it will make a bond. Because lone pair of electron is given to carbon. Then a new bond is formed between carbon and oxygen. And now one structure, that is a intermediate state structure will be formed. That is a new structure will be that RO, and with this O, C has joined carbon, carbocation, correct? Then now ROH, H was already there, ROH, that H is there, and one pair of oxygen is already there. Only one pair is donated to carbon. Then ROH, and with O, now carbon has joined. Then now carbon has 3 valency, it can join with other groups. And after that what will happen? That hydrogen which was present on or you can say which was attached with hydrogen, that will break because now oxygen is having 3 bond, which is not possible. One oxygen is related joined with ROH, then oxygen one bond, oxygen formed one bond with R and other bond with carbon, and originally one hydrogen was there, ROH, and that H will now leave as H plus because oxygen can't make 3 bond, only maximum 2 bond is possible. Hence here hydrogen will leave as H plus. Then now final product you will get ROC, where carbon has 3 valency. It can join with 3 group. This I have told you that this alcohol as a nucleophile. Now second I am telling you that first OH bond can break. That I have told you that OH bond broken. Now second I am telling you the bond between CO is broken when they react as electrophile. What I discussed, that was electrophile, because electrophile means what? Capital E plus, then positive charge is called electrophile, correct, and negative charge is called nucleophile. Okay, then now I am telling you now next second, the bond between CO is broken when they react as electrophile. Protonated alcohols react in this manner. Okay, now you can see how protonated alcohols act as a electrophile E plus. Okay, nucleophiles I told you that as nucleophiles, because oxygen has, in first case oxygen has donated 1 electron to whom? Then it was to carbocation. Then oxygen has donated 1 pair. Then because oxygen donated 1 pair of electron to carbon, then there it function as nucleophile. Correct? Nucleophile will be always having either lone pair of electron or negative charge. That is the nucleophile. Either have negative charge or have lone pair of electron. Now second case I am telling you protonated alcohol, because here another case C and O bond is broken, carbon oxygen bond is broken when they react as electrophile. Here electrophile means positively charged, E positive, E plus, and here H plus, correct? But in the nucleophile ROH was there, then OH, that O was having electron, 2 lone pair of electron, that's why it behaves as nucleophile. Now H will behave as a electrophile. And now in this case, what will the reaction? I am telling you. RCH2OH, this is the phenol, RCH2OH. Now if it will react with H plus, which is electrophile, then here what will happen? That carbon oxygen bond will break, RCH2OH. Then now OH is attached to carbon, then that bond will be broken. Okay, because H plus is coming. Then first what will happen? That this H plus, which is functioning as electrophile, it will come in contact with oxygen, and after that what will happen? Oxygen has lone pair of electron, then that will give 1 pair of electron will be given to H plus, because now H plus need electron, then 1 pair electron will be given by oxygen, then oxygen will have positive charge. Because 1 pair electron is given to hydrogen, then now it will form OH2. Now with oxygen 2 hydrogen is attached, and that oxygen is also attached with carbon. Then again here you can see same case, 3 total. Oxygen is making total 3 bond, but oxygen is having positive charge because it has donated one pair of electron to hydrogen. Same case what I discussed, that is above, as nucleophile. As nucleophile, there also after giving the electron, oxygen was having positive charge. Now then here it will break because now OH2 means what? H2O. It will go, bond carbon and oxygen will break, and oxygen was having positive charge. Now it is OH2. Then when bond will break, then electron will be taken by oxygen because oxygen is more electronegative than carbon. Then the this electron released by bond, after breaking the bond, that electron will be taken by oxygen. Now positive charge will go and it will form H2O. And now this you can say it will form temporarily. I told you temporarily it formed RCS2 OH2, but this bond, this plus OH2 means it is unstable because oxygen is making 3 bond. That's why this bond will break, carbon oxygen bond will break. But when will it break? That is the question mark. When will it break? Then now suppose any nucleophile like a bromide ion comes, then that time only it will break. Then suppose bromide ion is coming, or chloride ion, means any halide ion or any other nucleophile, then that nucleophile will come in close with this RCS2 OH2 plus OH2, which this is unstable. Then now when as for example bromide ion, suppose it is coming, then bromide ion has negative charge. Negative charge means it is a nucleophile. Then it can donate the electron. Then now this bromide will be, what will actually happen, that now in the presence of bromide ion, OH2 will leave as H2O, OH2 as H2O, and it will go with electron. O will take the electron, then positive charge of O will go, and it will become normal water molecule H2O, and carbon will have a positive charge. Why? Because electron released after breaking the bond, that is taken by oxygen. Carbon electron also taken by oxygen. That's why carbon will get positive. Carbon will get positive charge because its electron also oxygen has taken. Both electron. One oxygen, because in bond, during the bond formation, one electron was given by oxygen and one electron from carbon. Then oxygen has taken carbon electron also because oxygen is electron negative. And now carbon became positive charge. After breaking this bond, carbon-oxygen bond, carbon became positive charge. Then that time bromide will attack there. Means bromide, because it is negatively charged, it has electron, it will give electron to carbon, and new bond will be formed. Then new product formed will be BrCH2R. Okay, in the beginning only one R was there, correct? RCH2OH was there. Now that R is here. Now new product form is BrCH2R plus H2O. BrCH2R plus H2O. Then I have told you two type bond. Alcohols are, I told you, versatile compounds. They react both as nucleophiles and electrophiles. The bond between OH is broken when alcohols react with nucleophiles. Okay. Based on the cleavage of OH and CO bonds, the reaction of alcohol and phenols may be divided into two groups. Okay. Because both bond can break CO bond and OH bond. Then based on the cleavage of OH and CO bonds, the reaction of alcohols and phenols may be divided into two groups. First group, you can tell, reaction involving cleavage of OH bond. Reaction involving cleavage means breaking. It will break. Reactions involving cleavage of OH bond, and second will be reactions involving cleavage of CO bond. Okay. Then now one by one I will discuss. First, reaction involving cleavage of OH bond. Then in that first reaction, you can understand acidity of alcohols and phenols. Okay, acidity of alcohols and phenols. Both reaction, alcohols and phenols, both reaction, you can understand acidity of alcohols and phenols. First, reaction with metals. Alcohols and phenols react with active metals such as sodium, potassium and aluminum. And what product it will give? Then it will give corresponding alkoxide or phenoxide. Alcohol will give alkoxide, means ONA will join. ONA will join. That is the alkoxide. Here phenoxide means here with benzene ring, again ONA will join. Okay, ONA, sodium phenoxide, and when with it will join with alkyl group. Alcohol is alcohol. In case of alcohol, it will give alkoxide, and in case of phenol, it will give phenoxide and hydrogen, and it will release hydrogen. Now reaction you can see, 2 molecules of ROH, 2 molecules of ROH plus 2 sodium is metal, soft metal, plus 2 Na. You have taken both 2 molecules of ROH and 2 molecules of sodium, which is functioning as metal. Then again here same thing will happen, that H is positive charge, it will go as a positive charge. Why? Because this Na metal is there. Then now because 2 molecules of ROH is there, 2 molecules of ROH, then each molecule will release 1 hydrogen. Then it will form H2. Each hydrogen will have 1 electron. Then 2 hydrogen is there, it will release 2 hydrogen. Then it will form H2. And sodium also have 1 electron. Sodium metal also have 1 electron, just like hydrogen. Hydrogen has 1 electron. Hydrogen atom, sodium atom also has 1 electron. That's why it is happening. In the place of hydrogen, sodium will go and hydrogen is coming out. But you have taken 2 molecules of ROH, as each molecule will release 1H, having 1 electron. Then it will form H2. Correct? 1 electron both have, both hydrogen. Then H2 gas will come out. And what will be the product? Product will be alkoxide means sodium alkoxide. Sodium has joined in the place of hydrogen. Then it is called now RON, 2RON. It will form 2 sodium alkoxide because you have taken 2 alcohol. Then now we will get 2RONA, alkoxide. R means here alkyl group is there. That's why in general we are telling sodium alkoxide. Okay. Now if we will take particular, suppose you have taken butyl alcohol, tertiary butyl alcohol. Tertiary butyl alcohol is suppose you have taken. Then tertiary means carbon to which OH is attached. Carbon to which OH is attached, that's why it is alcohol. But this carbon is attached with 3-methyl group. 3-methyl group. CH3, CH3, CH3. Carbon is total 4 valency. The one is attached with OH. Other 3 is attached with methyl group. Then it is example of tertiary butyl alcohol. Now suppose you have taken 6 molecules. 6 molecules you have taken. That is the tertiary butyl alcohol. You have taken 6 molecules. And now as a metal you have taken aluminum. Aluminum you have taken as a metal. 2 aluminum you have taken. Then now what will happen? Here one aluminum, it is a metal. Then 3 electron will be with it. Okay. Aluminum, that is you will see the electronic configuration. Then 13, aluminum is having 13 electrons. Then if you write this thing, the atomic structure, then 283, 2 plus 8, 10, 3. Last orbit, 3 electrons are there. Then aluminum metal have 3 electrons. Then 2 aluminum you have taken. 6 molecules of tertiary butyl alcohol and 2 atom of aluminum. Then each atom have 3 electron. Then here total 6 electrons are available. And here now 6 molecules of tertiary butyl you have taken. Then now what will happen? You can understand that hydrogen will leave from there. Hydrogen will leave there. Then 3 hydrogen will leave. 3 in 6. These things 6 you have 6 molecules are there. Then 6 hydrogen will leave. And in its place, 2 aluminum will come. 2 aluminum will come. Because 2 aluminum is equal to 6 electron. 6 electron. Then 6 H is going and its place equivalent to this 6 hydrogen, 2 aluminum is coming. 1 aluminum is can make 3 bond with hydrogen. Correct? Because each aluminum has 3 electron. Then 6 hydrogen, it is equivalent to 6 hydrogen. Correct? Then now that this 6 hydrogen will go and its place 2 electron will come. Okay. And it will form, how will you write this? Then you can write a structure that in the place of that is CH3, 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 and from this CO oxygen was attached. Then this you can write whole 3 you can write, and outside aluminum will be there. Means aluminum has made 3 bond. Correct? Aluminum has means Al is joined with 3 CH3 butyl group, you can tell CH3, 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 and CO. C was attached with 3 methyl group and 1 oxygen. Then when H will go as a H plus, OH is there, then it will go as a H plus, then O will have 1 minus. Then here 3, it is a whole 2, means aluminum will make, is making now, because 1 aluminum can give 3 electron. 1 aluminum can make a 3 bond, correct? That's why whole 2, okay? Then that aluminum 3 bond it has made, okay? Then it has joined with oxygen, means 3 oxygen which is negatively charged with joined with 3 positively charged of aluminum. Then 1 aluminum is joined with 3 oxygen of this tertiary butyl alcohol. When hydrogen gone, that time oxygen got 3. This hydrogen gone and 3 oxygen have, each oxygen have 1 negative. Then aluminum made bond, correct? Aluminum and oxygen bond formed. Then like that way 2 aluminum you have taken. That's why this type of 2 molecules will be formed. 2 molecules will be formed. Then you can write that with aluminum you can write 3 oxygen aluminum bond formed. Then you can write that butyl group, you can write whole 3. Aluminum you can write aluminum outside in bracket you can write CH3CO, CH3, 3 methyl group and 1 oxygen you have written in bracket. Outside 3 is there, and this 2 molecules it formed, okay? See, all are equivalent to 6 electrons of aluminum and 6 electron of this thing hydrogen gone. Then 6 molecules means oxygen has 6 negative charge. That 6 negative charge is neutralized by 6 aluminum. That you can represent. Aluminum you can write outside, and you can write CH3 with carbon, 3 CH3 is attached and 1 oxygen is there. That whole you can write in bracket, and this is the 3, and outside 2. This is called aluminum tertiary butoxide. And here, because 6 hydrogen left, then it will form 3H2. Correct? Because all hydrogen have 1 electron. Then 2 hydrogen means 1H2. Then 6 hydrogen means 3H2. Correct? Always for understanding purpose, you can understand in both ways. That radical wise also you can understand, charge wise also you can understand. But radical wise reaction will take only in presence of UV light. But generally charge will be created when hydrogen will take it will go, that time it will go leaving the electron, because oxygen is more negative, hydrogen is electropositive, oxygen is electronegative. Hence hydrogen electron, 1 electron of hydrogen will be taken by oxygen. Then here that way also you can understand. That charge will create. and if you will think, can say all the things in a correct way, then you will find charge, positive charge and negative charge is going to be neutralized. Okay. Then this I told you, it formed aluminum tertiary botoxide. This reaction is important. Okay, because here bond formation is a little not difficult, because aluminum is 3 positive. It has 3 electrons, and each oxygen, 6 were there, 6 negative electron is there, means a negative charge electron. Hence 2 aluminum will join. Very simple way. Okay, 2 aluminum will join. That's why you are writing outside coefficient 2, coefficient 2. Then just like AlCl3 you are writing, AlCl3, like that way in the place of Cl you write butyl group. You write the butyl group. Then whole 3 you have to write AlCl3. Then in the place of Cl you write butyl group. Only it will look big, but easily you can write. And outside 2Al3 like that, 2AlCl3 aluminum trichloride like that, 2AlCl3. Then 2 here you have to write outside. Then this is also alkoxide. Which alkoxide? Then salt, this metal name you have to write. Tertiary, or you can write aluminum tertiary botoxide. Metal name you have to write. So just like sodium alkoxide, here you write aluminum tertiary botoxide. Now that related to phenol, one reaction you can see. Same type of reaction with phenol. Now this reaction takes place with sodium. 2 sodium. 2 phenol you have taken, means with benzene OH group is attached. That is the phenol. Then 2 molecule phenol you have taken, and 2 atom of sodium you have taken. Then again situation will be the same. H will go, and then 2 phenol is there, then 2 H will go. Then it will form H2. It will form H2. And now that in the place of H, sodium will go, because sodium also have 1 electron. Sodium metal have 1 electron. Then in the place of H, sodium will go. Means substitution. Then now only substituted with hydrogen. Then in the place of H, sodium gone. Then it is called phenoxide, because now it is sodium is attached with oxygen, ONA, and O is attached with phenyl group. That's why it is called sodium phenoxide. Then it will form 2 molecules of phenoxide, because 2 phenol you have taken. Actually, why 2 you have taken? Because if you will take only one, I can say phenol, then it will reach only 1 H. Then in 1 H, molecule will not form. For H2 gas, 2 H is required. For H2, 2 H is required. For that purpose, you have taken 2 phenol. Or even for 1 phenol, you will take 1 phenol plus 1 sodium. Then that time hydrogen gas will be formed, but it will be half H2. Better for easy understanding, you take 2 phenol plus 2 sodium. You will get 2 molecules of sodium phenoxide. Now this I told that with metal. Now in addition to this other reaction I am telling you, in addition to this, phenols react with aqueous sodium hydroxide. It can react with NOH also, aqueous. Actually you have to make NOH is solid. then you have to dissolve in water, then it will be solution will be formed. Then that solution is called aqueous solution. Aqueous solution, because you have made the solution in water. And now suppose that solution you have taken, then phenols react with aqueous sodium hydroxide to form sodium phenoxide. In this case also it will form phenoxide. How it will form? Then phenol plus NOH. OH is there, and H will come from phenol. Then it will form water, because from there H will release as H plus, and here NOH, OH is negative, then H plus and OH minus, it will form water, H2O. And now sodium is positively charged, that will go to the negatively charged oxygen, because H gone as a H plus, then oxygen is negative charge, and sodium is positive charge. It will join there, it will make bond ONA. Then this is called sodium phenoxide. Okay, now this above reaction show that alcohol and phenols are acidic in nature. This also gives a proof that it is a proof that it is acidic in nature, because hydrogen is released. Any substance which releases hydrogen, H plus means proton, that is called acid. It means phenols and alcohols both behave as acid. Okay, the above reaction show that alcohols and phenols are acid in nature. In fact, alcohols and phenols are brown acid acids. Always remember. In fact, alcohols and phenols are brown acid acids. That is, they can donate a proton to a stronger base. Then here, what was the base? NOH was the base. NOH was base. Correct? Then now, in a general way, I am telling you, any base will have electron. A pair of electron it will have. That is this B, you can write base, you can write B, and one negative charge, and one pair of electron you can write 2 dot, you can write that is showing 2 electron, and it is negatively charged. That's why B negative having one pair of electron means 2 point you can represent as electron, that is the base. Then that base will react with acid like ROH. Correct? Then now that base can give the or donate the electron to H, can donate electron to H, then it will form BH, conjugate acid, because electron is taken by hydrogen. It is taken, actually base, what is the characteristic of base? Base always donate the electron, remember, and acid will always release the proton. Always remember, base donates the electron. A pair of electron will be donated by base, and who will take this electron? Then hydrogen will take H plus. Why you are writing? You know that hydrogen has one electron, that also is taken by others. Then now one positive charge, but to make the bond 2 electron is required. That's why base will give one pair of electron to the hydrogen. Then it will form conjugate base BH, and after but this H was attached with acid like alcohol. Then if H will, then now this alcohol is acid, because acid characteristic is it donates the proton, it releases the proton. That proton is gone with sodium, sodium will give electron, then there it will make the bond BH. And now this hydrogen electron is taken by oxygen, then only OR negative will remain. Now OR will remain. After leaving the relieving the H, OR will have one negative charge, means one more pair of electron will be there. Now 3 pair. Always oxygen will have 2 pair. Now when bond will break, that time one more pair will be there, 6 electron, and it will be negatively. Then after releasing the hydrogen, H plus means proton, it will be called conjugate base. Conjugate base. Then base after taking the hydrogen, it is called conjugate acid, because H is there. Wherever H will be there it will be acid. That will be called acid. And only same time base is formed. Then negative charge ion, negatively charged ion means anion, that will be conjugate base. Now why conjugate base? Because again it is in a position to donate electron to the others. To the others hydrogen can give. That's why during the reaction, base and acid, when it will react, then it will form, base will become conjugate acid and acid will become conjugate base. Now this I have discussed acidity of alcohol and phenols. Now again you see acidity of alcohols. Furthermore, acidity of alcohols. The acidic character of alcohol is due to the polar nature of OH bond. Correct? OH bond is polar because it has positive and negative. Means oxygen is negative, hydrogen is positive. This is called actually polar nature. The acidic character of alcohol is due to the polar nature of OH bond. The electron releasing group, example of electron releasing group, methyl group, ethyl group. Suppose it is attached. If it is attached, then what will happen? An electron releasing group increases electron density on oxygen. If with acid, means in alkyl group R is there. If you can say CH3 is attached or ethyl group is attached, then this is electron releasing group. Electron releasing group means it will supply the electron. Then on oxygen more electron will be available. Then what will happen? This increases electron density on oxygen, tending to decrease the polarity of OH bond. Polarity will be decreased because now it will get more electron. Okay, this decreases the acid strength. This decreases the acid strength, because here electron releasing group is attached. As for example, methyl group, ethyl group, it is attached. Then near the oxygen, more oxygen electron will be available. More electron will be available. Okay, due to that because hydrogen is there, hydrogen wants electron, and now oxygens are having more electron, then it will be always giving electron to hydrogen. Then hydrogen will not leave from there because it is getting more electron, hence it will not leave oxygen, because now on oxygen is getting more electron due to methyl or ethyl group. Hydrogen will not leave the place. Means it will not show acidic character, because proton will release only, then it will be called acidic character. It means if methyl or ethyl group, any electron releasing group is attached with oxygen, then acidic character will decrease. Acidic character will decrease, H will not leave. And just a reverse way, if electron withdrawing group is attached, then that situation there will be on oxygen electron will be not available. Electron will be not available to give electron to hydrogen. That time hydrogen will leave quickly, because it is not getting the electron. Why will it stay there? And that time its acidic character will increase. But now here you understand that electron releasing group is attached, like methyl or ethyl group. It is attached to oxygen. Then it increases electron density on oxygen tending to decrease the polarity of OH bond. Means charge, H will not go. Means there will not give clear, it will not create clear cut positive and negative charge. It will be attached only. It will create charge only, it will create polarity only when H bond will break, H plus and O minus. But it is not breaking, hence charge will be not created. Means there will be no polarity. Polarity decreases the polarity of OH bond. This decreases the acid strength. Acid strength depends upon the release of hydrogen, but hydrogen is not releasing, correct? That's why strength will decrease. This decreases the acid strength. For this reason, the acid strength of the alcohol decreases. I am telling you a few examples that order of that which group will you can say will be more you can say stronger, and which will be weaker. I am telling you. Okay. For this reason, the acid strength in order I am telling you. Order of acid strength. Then primary alcohol. Primary alcohol means carbon to which oxygen is attached. That carbon is attached with only one carbon, one methyl group as for example. R. Mean if it is a primary, then primary will be will have more acidic strength than secondary. Means when two methyl group is attached or two alkyl group is attached, then primary will have more strength than secondary, because in our secondary two alkyl group is there. Then it will release more electron than on the oxygen, more electron will be there. Then now hydrogen never it will leave, because now more oxygen is there, then it will be always attached there. Then primary will be, you can say, more primary alcohol is more acidic than secondary alcohol, and secondary alcohol is far you can say there this will be strength will be more than tertiary, because in tertiary 3R is attached, then 3 alkyl group will will give electron to oxygen, hence never hydrogen will go. Then primary alcohol is stronger than secondary, and secondary is far stronger than tertiary alcohol in term of acidic strength, acidity. Primary alcohol is stronger than secondary, and secondary is stronger than tertiary. This question is actually asked many times. Question has been asked. Now this base as a base. Now you consider alcohols. Alcohols are, however, weaker acid than water. Now alcohol you are comparing with water. You know that water behaves as acid as well as base. You must remember, water behaves as both as acid as well as base, because H, sometimes it can release H, then that time it will show acidic character. Sometimes it can release OH minus, then that time it will show basic character. Or sometimes you can tell that H2O can take the electron also, and because oxygen has 2 lone pair of electron, then it can give also. When it will give, then that time it will be base. Correct? And when hydrogen will go leaving its electron, then that time it will be acidic. Then it can behave both way. Water can behave as acid as well as base. Okay. And now you can see you are comparing this water with alcohol. Alcohols are, however, weaker acid than water. This can be seen by the reaction of water with alkoxide. Reaction of water with alkoxide. You can see the situation or reaction. Then RO negative charge, then it is actually alkoxide. Now water is there. Water is H2O. H2O you can write HH. In the middle you write oxygen, and oxygen have 2 lone pair of electron. Correct? Then now what will happen? That now RO which is negatively charged, that can give the electron, because this HOH water, when water will release one H, suppose it releases as H plus. When water behaves as acid, it will release H plus, and that H plus will go to the base, means RO, phenoxide RO. That will give electron to the hydrogen. Then now it will form ROH. RO was basic, now it became acid. Base became acid, that's why it is called conjugate acid, because H now joined with base. Then now that base will become conjugate acid. Base becomes acid, and acid, after releasing H, it will behave as a conjugate base. Remember, base becomes acid becomes base. But that time you use the word conjugate because same time it happens. As soon as acid, means water, will release hydrogen, that time only it become base, and H, as soon as it comes near the base, that becomes acid. Then here you have seen how water behaves as acid. This reaction shows that water is a better proton donor. That is a stronger acid than alcohol. Also, in this reaction, we note that an alkoxide ion is a better proton acceptor. Why? Because here three lone pairs are there. RO minus, that oxygen is have 3 electron pair, means 6 electron. Then one pair, how it came? Generally oxygen have 2 lone pair of electron, but here it is a 3 pair of electron. Then RO minus anion is there. This alkoxide, what we are telling, it means from that hydrogen gone that time, their electron it was having. That's why 6 pair. 3 pair. 3 pair means 6 electron. 3 pair. That's why it can, if you compare, then now these things, in water O was having 2 pair, but here in RO base 3 pair. 3 pair. Then only on that basis you can tell this reaction shows that water is better proton donor. Better proton donor, because oxygen has only 2 pair electron. But hydrogen will think to go there where it will get more electron and easily. Then now on base 3 pair of electron is there. Then they will leave this. Proton will leave from water. One proton will leave from water, because now that base is there that have more electron. Then this easily it will go. If this H from the water, it will go to the base. Then easy going of proton or easy releasing of proton. If any substance is releasing hydrogen very easily, it means that substance is more acidic. More acidic. Any substance which is releasing more hydrogen or fast, easily, then that will be a stronger acid, because they are releasing fast releasing and in more quantity. Then it will be a stronger acid. And base who are in a stronger base means who can donate more electron. That is a stronger base. Then now acid strength you can see, because in water oxygen has 2 lone pair of electron, and now base has 3 pair, as that water will release 2 hydrogen, because now base is attracting that hydrogen. Then hydrogen is coming from water to base. That's why because oxygen are only 2 pair, it is a stronger acid than alcohol. A stronger acid than alcohol. Okay. Then this reaction shows that water is better proton donor. Better proton donor means a stronger acid than alcohol, because alcohol phenoxide ion is taking that electron. Also in this reaction we note that an alkoxide is a better proton acceptor than hydroxide ion, which suggests that alkoxide are stronger bases. Sodium ethoxide is a stronger base than sodium hydroxide. Question is asked. Sodium ethoxide, because sodium ethoxide that is it will be ionized form. Sodium ethoxide, then ethoxide means alkoxide, you can tell it will form alkoxide and sodium. In water it will be separated. Correct? It will be separated. That's why alkoxides are a stronger base, means sodium ethoxide is a stronger base than sodium hydroxide. Okay. Alcohols act as a brown acid bases as well. Alcohols act as a brown acid base as well. It is due to the presence of unshared electron pairs on oxygen, which makes them proton acceptor. Because proton will be, they will come like H plus, that is the proton. Without electron it is coming, and this base can give the electron to proton. That's why alcohols act as a brown acid bases as well. It is due to the presence of unshared electron pair on oxygen, which makes them proton acceptors. Now I am discussing I am going to discuss acidity of phenols. Alcohol I told you. Now see the situation in phenol. Then here you have to see the resonating structure of phenol. Okay, the reaction of phenols, the reactions of phenol with metal, maybe sodium, maybe aluminum. The reaction of phenol with metals like sodium, like aluminum. Then this phenol and sodium hydroxide, suppose reactions are going on. The reaction of phenol with metals and sodium hydroxide indicate its acidic nature. Phenol shows acidic nature in presence of a metal or in sodium hydroxide. Okay. The hydroxyl group in phenol is directly attached to the sp2 hybridized carbon of benzene ring. That you know. If you are not knowing, already I discussed many times. Now again I am telling you, the hydroxyl group means OH group. The hydroxyl group in phenol is directly attached to the sp2 hybridized carbon. In benzene ring, all carbons are sp2 hybridized. Wherever double bond will be there, alternate single and double bond, that will be sp2. Only 3 orbitals will be available to make the bond, that is the sp2. The hydroxyl group in phenol is directly attached to the sp2 hybridized carbon of benzene ring, which acts as an electron withdrawing group. That carbon, okay, remember sp2 carbon is sp2 hybridized carbon of benzene. OH group is attached to the sp2 hybridized carbon of benzene ring, which acts as an electron withdrawing group. Due to this, the change due to this charge, you can tell charge distribution in phenol. Charge distribution in phenol molecules, you can say, forms resonance structures. Resonance structure charge will be distributed. Then this resonant structure charge will be distributed. Charge distribution will takes place. Okay, and this resonance structure cause the oxygen of the OH group to be positive. Correct? Because electron will be taken by the ring. Then what will happen? This cause the oxygen of OH group to be positive. Oxygen will become positive. We will find very less time oxygen will be positive. When it will supply electron to the others, only that time it will be positive. Then here OH is attached to the benzene ring, and that carbon is sp2 hybridized. It will withdraw the electron, it will take the electron, it will attract the electron. Then here actually four resonating structure will form. Already I have discussed that. I will tell you quickly, will understand. OH is there, and then in that O is having two pair of electrons. Okay, lone pair of electrons too. Then it is attached with carbon. Then now that one pair of electron will give to the, now it is single bond. When it will give one more pair of electron, because benzene is a electron withdrawing group. Then due to that reason, now one pair of electron will be given by oxygen. Then now single bond will become double bond. Then that two double bond can't be there, because in the benzene already one double bond was there. only from there OH was attached. Then when oxygen will donate one pair of electron, then continuous two lone pair, two double bond will be there. Then it is unstable. It will become unstable. Then benzene double bond will switch over. It will break. It will break, and next carbon will take that electron. Next carbon will take that electron. Bond will break. Ring double bond will break one bond, and it will carbon will take that electron. Correct? That will become negatively charged, that carbon ortho position. And after that, rotation will take place, because that carbon is having two electrons. Then that will give to that can make again double bond with next carbon. And then again next continuous two double bond will be there. Then that bond will be disturbed. Then that bond will break, and it will go and electron will go to the next carbon. Correct? Next carbon. Then like that way complete rotation will be there. Distribution of charge will be there. Wherever this electron will go, and this will go electron, after the breaking the double bond, it will reach, that carbon will have two electrons that can give to the next carbon, and next double bond will break and it will give to the again further next carbon. Like that way charge distribution will be there. And finally that ortho position negative charge will, after the fourth structure, or you can say fourth structure, in fourth structure only, because this carbon will make finally three double bond only. Okay, so this will go to the three carbon, means ortho carbon now reach to the, you can say, other side, means carbon number 2 now reach to the carbon number 6. Electron which was at ortho position now reach to the, after moving meta, para, again ortho, then para, next side means carbon number 6, it reached with negative charge. Then now here already carbon and oxygen double bond was formed. Then now one pair electron is there. Then due to this repulsion, that C and O bond will break, and again, and oxygen was having positive charge, that electron it will take, and now there it will form double bond. Yeah, as soon as that bond will, carbon oxygen bond will break, only that time this carbon number 6 was having two electron, that will make bond with 6 and 1, first and sixth carbon. Then you see where double bond was there, that became single bond. Where single bond was there, that became double bond. There is a rotation of charge or distribution of charge in phenol. Okay. The reaction of phenols, then actually this charge distribution I told you, rotation of charge, finally you can write just like a circle in a side. Benzene ring, one circle you can put. This means that electrons are moving, it is not fixed. Phenol you can write like that way, OH group is attached in benzene ring and inside one circle is there. Now further I am telling you, the reaction of phenols with aqueous sodium hydroxide indicate that phenols are a stronger acid than alcohol. The reaction of phenol with aqueous sodium hydroxide, then sodium hydroxide is base and it is reacting with phenol. It means phenol is acid, that's why it is reacting with base. The reaction of phenol with aqueous sodium hydroxide indicates that phenols are a stronger acid than alcohols and water. You remember, question is asked. The reaction of phenol with aqueous sodium hydroxide indicate that phenols are a stronger acid than alcohol and water. Okay. Then now this happened due to the resonating structure. Phenoxide ion is stable. Okay, that's why it is a stronger acid than alcohol and water. Now we should examine how a compound in which hydroxyl group attached to an aromatic ring is more acidic than one in which hydroxide group is attached to an alkyl group. Means now effect of OH you can see. OH when it is attached with benzene ring and when it is attached with alkyl. That time what will happen? How will it affect the acidity? Okay, that you can understand. Then here you can see that this ring I am telling you, here when OH is attached, they have to they see a compound in which hydroxyl group attached to an aromatic ring is more acidic. If OH group, if you can say OH group is attached to an aromatic ring, it is more acidic than one in which hydroxyl group is attached to the alkyl group. When OH is attached to the alkyl group, then in comparison to that, phenol will be more acidic. How? Then now you can see ROH, that is this is the alcohol. Then alcohol will ionize like RO minus plus H plus. Means it will give quickly, it will ionize phenoxide. Phenoxide means RO1 minus plus H plus. This happens in case of alcohol. Okay, and both are in equilibrium. Both are equilibrium means ROH will convert into RO plus H plus. Again it will come back. Reversible reaction. Reversible. Again RO plus H plus proton means alkoxide plus hydrogen. Again it will give back ROH. But in alcohol you can see, alcohol also here you know that OH will ionized. It will give phenoxide. Phenoxide means phenol, H ion will go. It will break into phenoxide plus H plus. Okay, it will also give like that way, phenoxide ion plus proton. Then due to the higher electronegativity of sp2 hybridized carbon of phenol to which OH group is attached, electron density decreases on oxygen. This is the main reason. OH group is attached, its effect you can see due to the higher electronegativity of sp2 hybridized carbon. sp2 always they will try to attract the electron. It is sp2 is always electronegative. Okay, then due to higher electronegativity of sp2 hybridized carbon of phenols to which OH is attached, electron density decreases on oxygen. On oxygen, less electron will be available. This increases the polarity of OH bond and results in an increase in ionization of phenols, that of alcohols. Means here it will ionize fast, means it will release more hydrogen or quickly it will release. Hence phenols are stronger than alcohol because this situation alcohol will release slowly. Hydrogen will release proton but slowly. And due to sp2 hybridized carbon, now on oxygen hydrogen will be less, hence it will polarize quickly. But this is the not case. This is the not case with alcohol. Okay, alcohol, this will be not the case. There, if we more oxygen will be there. On oxygen in phenoxide, RO, more oxygen is available. Then hydrogen will not go because it is getting electron. It will not go. That's why that is that will be not polarized. Hence alcohol will be weak acid in comparison to phenol. Okay. Then this I have discussed about the why alcohol is more acidic than This phenol is more acidic than alcohol, I told you, and alcohol is more acidic than water, that also I discussed. Means phenol is superior in comparison to 3. Okay. And next class again I will continue that. Again little is remaining, I will discuss next class. Again many properties are there that I will discuss in the next class. Thank you.